Good morning, Rio Grande third graders. It's Monday, March 1st. It's our first day of March. We're 3/4 of the way through school almost, and wow, that is amazing, right? So let's take a look at our DMA problems for today. We have the first problem is a fraction, and it says, let's write the fraction for the following shape. Now we're going to assume that they are talking about the parts that are shaded, okay? So we know that this circle, this figure is our circle. We know that it's broken up into 4 equal pieces. And each one of those pieces is a unit fraction of 1/4. So this is 1/4 of my circle. This is also 1/4 of your circle. This is 1/4. And this piece right here is also 1/4 of the whole. So now it says, write the fraction for the following shape. We're going to assume that they're talking about the shaded parts. So 1, 2, 3, that's my numerator. Those are the parts that I'm counting of the fourths. And my total number of parts in the whole is my denominator. And I have 4 equal parts. So this is my denominator, this is my numerator, and we say this as 3/4. Please be sure to label each one of those parts as 1/4 on your paper. Okay, let's take a look at the next problem. It says, write the missing numbers to complete this pattern. So if you notice that these are multiples of 3, which means when I count by 3s and add 3 more each time, these multiples of 3 will continue forever. So let's take a look at 3, add another 3, that's 6. Wait a minute. Now that doesn't necessarily follow a multiple of 3, does it? So let's take a look a little bit closer at this pattern. Because however these are multiples of 3, we're missing something between the 6 and the 12. We would be missing 9, so we're not adding by 3. So let's take a closer look. What happens when we go from 3 to 6? Well, we do add 3 there. But what happens when we go from 6 to 12? Well, it's 6. So it seems like to me that we're doubling each time we go. So when we double something, that means we multiply it by 2, correct? And so if I multiply 12 by 2, or I double this 6, I would be adding 12 more, which is a double of 12. So 12 plus 12 would be 24. Now, what happens if I double 24? Because that's what I'm doing. I'm going to double this. So I'm going to double 24. I'm going to multiply it by 2. So 24 plus 24, correct, is 48, because I'm doubling this, right? I'm doubling it. What happens if I double 48? What happens if I double 48 and add 48 and 48, or multiply it by 2, right? Because that's what's happening. I'm multiplying 48 by 2, because that's what double means. I multiply by 2. So 8 and 8 is 16. 40 and 40 is 80, plus this 10 that I just received from the 16 would be 96. So that one was a little tricky because it seemed like we were going to be adding by 3s. However, we noticed that when we said 3, 6, oops, 9 is not there. So really we weren't counting by 3s, but we can see that this is going to double every time. So I double every time. So what's the rule? the rule is we are going to double our number. So that one was a little tricky. We've got to really pay attention to those patterns, don't we? All right, let's take a look at the paper clip. The length says how many inches long is the paper clip? Well, you can see that it's in between whole inches. It's in between the 1 and in between the 2. So this tells us it's not exactly 1 inch and it's not exactly 2. It's in between whole numbers. And what happens when we're in between whole numbers? We are working with fractions. Right, we're working with fractions. So if I line up this paper clip with between my 1 and my 2, I can see that right here is right in the middle of this 1 and this 2. So this is going to be our half point. So we have 1 full inch, which we're going to write here, and we have half of another inch. So when we write this, we are going to say 1 and a half inches. 1 and a half. 1.5 inches long. So the paper clip is 1.5 inches long. We have our division equations. We have 12 total objects. So let's say, for example, if I had some oranges, I'd have 12 oranges. If I wanted to put them into 4 equal groups, I'd have to share them into the 4 groups. And then I would have to find out how many oranges would go into each group. So my question for the word problem would be, how many oranges are in each, let's say, bag? So Mrs. Jaramillo wants to take her 12 oranges and share them equally into 4 bags. My bags are my groups. The question would be, how many oranges are going to be in each bag? Or if I knew the information of Mrs. Jaramillo has 12 oranges, she puts 4 oranges in each bag, then my question would have to be how many groups I have. And I could say, how many bags will Mrs. Jaramillo need to put the oranges in? So either way, it's going to still going to work. So we could go by 2's to start with. 2, 4, 6, 8. Now, this is getting pretty close to 12, so we want to probably go by 1's now. 8, 9, 10, 11, and 12. So, how many oranges are in each bag? I have 3 in each. Remember, we can always check our our division using multiplication. So if I knew I had 4 groups, if I know my multiplication facts well, which we should start knowing fairly well by now, right? 4 groups of 3 in each group would give us 12 total. And 3 plus 3 plus 3 plus 3 is 12. Let's take a look at our next one. We have 10 objects. Okay, well, let's pick some objects. What objects would we have 10 of? Well, let's try paper clips since I'm looking at a paper clip here. Ms. Jaramillo has 10 paper clips. She's going to put 5 pieces of paper together. How many paper clips is she going to need? So 10 paper clips. I have 10 paper clips. I'm going to put together, oh, that doesn't make sense. Oops, I need to think about this a little more carefully. Let's take 10 pieces of paper and put them into groups using paper clips. I think that makes much better sense. So if I have 10 pieces of paper and I put 5 groups or 5 pieces of paper in each group, how many groups am I going to have, or how many paper clips am I going to need for my groups of paper? So 10 pieces of paper, 5 pieces of paper in each group. And I was going to do an array, but I think I will. 5 pieces of paper here, 5 pieces of paper there. That's a group of 5. This is a group of 5. So 5 and 5 makes the 10. So now I know that I have 2 groups of paper. I was going to do an array, but I thought that might confuse you, drawing those pieces of paper out. So I just put a stack of 5 here, a stack of 5 here, and then use that to understand how many groups of 5 I have. I have 2 groups of 5. Now I look at 9 groups of 6. This is multiplication. I have 9 groups of 6. 9 groups of 6 means I'm adding 6 plus 6 plus 6. That's 18. There's 3 groups of 6. 6 plus 6 plus 6. That's 6 groups of 6, which is another 18. And 6 plus 6 plus 6. That's 9 groups of 6. And now I have another 18. So 10, 10, 10 is 30. 10, 20, 30. 8 plus 8 plus 8 is 24, because 8 groups of 3 or 3 groups of 8 is 24. Together, that makes 54. So don't guess at what the product is of your factors. Make sure you show your work and figure it out using a strategy. You have many strategies. You could actually even count by sixes. 6, 12, 18, 24, 30, 36, 42, we're getting closer, 48, 1, 2, 3, 4, 5, 6, 7, 8, one more group, 56. No, sorry, 54. 42, add 6, 48, 54. Okay, 54. So that is our product. Product is the answer to a multiplication sentence. Now, your multiples of 6 are showing the products of your multiplication fact, but we call these multiples because we are adding a group of 6 every time, and these are the multiples of 6 when we keep adding that group of 6 on to each number. So if I added another group of 6 here, right, this would be 60. And 60 is the product of 6 times 10. But again, it's one of those multiples of 6. So today in your discussion question, you're going to take the unshaded part of our circle, and that's going to be your discussion question for your answer for the discussion question today. What fraction of the circle is unshaded? Again, what fraction of the circle is unshaded? Unshaded. Okay, I will see you guys in small group today, and have a very wonderful day.